So now let us use Monte Carlo techniques to approximate pi. So for this purpose, you first draw a circle of radius 1. So this is a circle of radius 1, and you have your target area. So let us draw our target area. So target area has a circle in it. So this is our target area. So we are doing step 1 of Monte Carlo integration method, that is you draw your target area. So this is our target area. Circle is completely contained in this target area. And so what is the area? So this is obviously 2 because you have 1 here and 1 here, and similarly this is 2. So 2 times 2, it is 4. So this is your target area. So the area of this circle is pi r square. So we said radius is 1, so the area of this circle is pi. So now what you do is you throw darts in this target area. So let us throw some darts in this target area. So we're just throwing some darts in the target area. So now what you do is that you have to calculate the proportion of darts which landed inside the circle. So if the dart lands inside the circle, then its coordinates have to satisfy x square plus y square is less than equal to 1. So obviously the area of the circle is x square plus y square is equal to 1. So that is the area of the circle. So if you put less than equal to 1, you find that this is the area inside the circle. So what is this x and y? So every point you throw, in here has 2 coordinates. So there are 2 coordinates for this point. There is x coordinate and there is y coordinate. And if this lies inside the circle, then this will satisfy this condition. If it lies outside the circle, then obviously x square plus y square will be greater than 1. And this is what we will use to count the number of points. So this is our function. We call the function as pi. This function pi will take 2 values as input, x and y. So these 2 are input in the function. So you have x square plus y square is what pi will be equal to. So n is 100,000. That is, this is the total number of darts you throw in the target area. Now you want to find points under or points in the circle. So for points in the circle, you apply pi. That is, this is x coordinate and this is y coordinate. Again, x coordinate is you're drawing random numbers from uniform distribution. R for random, unif for uniform. X lies between -1 and 1. So between -1 and 1, x lies in. So there are 2 points x, and similarly y also lies between -1 and 1. And this should be less than 1. You can put it less than equal to, but that is not going to make much of a difference. So if this condition is true, then you can sum up all these points. So this will give you total number of points which lie inside the circle out of 100 and 1000. So now you can compute the proportion, point under by n times the target area, which is 2 by 2. So this should give you value of pi. So we know that approximate value of pi is 3.14. So let us do the Monte Carlo method and see what comes out. So let us run this. So you see, out of 100,000, 78,608 points lie inside the circle, and our answer comes out to be 3.144. So you can do this a couple of times. Every time you do it, you will get a different answer. Now you get 3.139. So it will always fluctuate around 3.14.